Hello, my name is Theo Dawson, and I work with a nonprofit called Lectica that specializes in building learning tools that are scalable and also backed by Piagetian constructivist theory. This presentation is going to be about the calibration of our electronic scoring system, which is called CLAS. So the development and calibration of CLAS is now a 23-year journey. We've been at this for a long time. So in this slideshow, I'm going to really quickly and just skimming the surface tell you about CLAS. I'm going to talk a little bit about the dimension called hierarchical complexity, or we also call it the lectical scale, to which CLAS is calibrated. And then the human scoring system that preceded CLAS, which was called the electrical assessment system, or is called the electrical assessment system, and a rubric scoring system that we created and as part of the journey. And then I'm going to talk about calibration results for the LRJA, which is our reflective judgment assessment. CLAS differs from other solutions to automated scoring in several ways. First of all, it is deeply grounded in Piagetian and neo-Piagetian theory. Its scores are tied to a large and evidence-based developmental taxonomy of meaning called the Lexical Dictionary. I know that's a mouthful and a headful. It can readily be calibrated to track development in a wide range of subject areas, and it's the core of a platform that we have built for delivering many skill-specific assessments that are designed to support optimal learning. A little bit of context around this. The creation of accurate and reliable electronic scoring systems, specifically for texts, has been called the Holy Grail of educational assessment. And to date, most of these have been created through the computational analysis of essays that have either been scored by humans with a variety of conventional rubrics or through the analysis of graded texts, which are texts that have been determined through expert opinion to be suitable for specific school grades. These scoring systems focus primarily on aspects of text that lend themselves to computational analysis, such as sentence length and syntax, morphology, punctuation, size of vocabulary, etc., etc. Some of the developers of these instruments claim to measure constructs like meaning, but I really think that these measurement claims are very difficult to evaluate, partly due to a lack of clarity about the meaning of these terms within the context of measurement systems, and also the paucity of actual published evidence. So let's talk about CLAS and where it came from. We started with an assessment system called the Lexical Assessment System, which is based on Fisher's skill scale. That scale describes a series of hierarchically nested levels or stages, and it includes 5 tiers with 4 levels per tier. The 4th level in his scheme is the first level of the following tier, so it's easier sometimes to think of it as 3 levels. Scoring texts with the lexical assessment system requires determining the structure of arguments and the highest level of abstraction of the meanings embedded in them. And this is a lot harder than it sounds. It takes several years to actually train someone to do this well enough to be able to score accurately. So the rationale for CLAS is based on features of the Fisher's model as well as Piagetian theory. So in Fisher's model, each new developmental level builds upon the previous level in a hierarchical fashion, and you can see this represented in the image on the right. New meanings build upon and transform earlier meanings in this model, which means that later meanings are more integrated and differentiated than earlier meanings. CLAS is designed to look at the distribution of meanings in verbal performances. Okay, so let's talk about how that works. This happens by CLAS recruiting the Lexical Dictionary, which, as I said before, is a curated taxonomy of meanings. In this dictionary, words and short phases, which we call lexical items, are assigned to phases, which are 1/4 of a skill level, based on the phase at which their simplest possible meaning is likely to become useful. And placement of these is determined by highly trained analysts based on a combination of evidence and theory. And it is constantly being reevaluated as new evidence emerges. So the whole system is designed to be highly iterative. It's in a constant state of transformation. But because there are so many terms in the dictionary, this constant iterative activity has very little impact on the system as a whole, at least in the short term. At the time of the calibration study that I'm reporting on here, there were over 180,000 lexical terms in the dictionary, and now there are well over 1 million and growing rapidly. So what CLAS does is it examines the distribution of these lexical items across phases within verbal performances. And then it matches these distributions to predicted distributions in a discriminant function-based algorithm. Now, on the right side of this page, I'm just using truth as an example to show you how the conception of truth, the meaning of truth, changes over time, and how that can be seen in the way that it's constructed in short phrases. All right, so this is how CLAS sees development. On the left, we have the score for a given performance, or the potential score for a given performance. And this is done by phase in this particular case. It's much more granular than that actually in that true scoring algorithm right now, but we couldn't capture all of that in a single image. For our purposes here, this is plenty granularity. So we've got the score itself, or the phase score on the vertical axis, and then on the horizontal axis we have the density scores, and these are the densities of the expected densities of lexical terms in performances at different developmental phases. It's easiest actually to see what this all means by looking at what the distributions look like when they're mapped out. And as you can see here, there is just a kind of steady step-like kind of movement to the right of for the distribution of this curve as we develop over time. Okay, so let's take a look next at the instrument. And by the way, I know that was a really inadequate explanation of CLAS, but at least it gives you a little bit of a visual, and you can go back and play around with looking at that a little bit more closely later, or right now if you'd like. So let's take a look at the instrument. So the instrument that we used for this particular study was the LRJA, which is focused on a broad range of skills, but that we say they're required for managing chaos, and chaos is competing ideas, accelerating change, information overload, and social division, which I think basically captures the reality of our times. The skills targeted in various forms of the LRJA fall into 7 broad categories, which we think of as self-mastery, working with perspectives, conflict resolution, gathering and evaluating information, contextual thinking, experimentation, argumentation, which we also call clarity, and decision making. And we call each one of these categories a mega skill. So it's a big skill that's got lots of little skills in it. And for you to get a sense of what this means, here's the clarity map. This is the map that we use for the clarity skill. And you can see in the middle is the word clarity. And then we have logical coherence, framing, persuasiveness, and clear communication. In the next level out. And then finally, in the very fringes, we have what we call micro skills, which are defined as skills that are so small that they can actually be practiced on the fly in context, in everyday contexts. And this is very important. This is the kind of thinking about skills that is behind everything that we do here at Lectica. Okay, so let's take a look at the LRJA. Prompts for the LRJA include things like some scientists think that violent TV shows are bad for children. Others think some violent shows are okay. Which group do you think is right? Please explain. Or how is it possible that the two groups of scientists have such different ideas? Please explain. What we're trying to get at is the way that learners are thinking about how they would go about dealing with this kind of conflict. And we ask specific questions to get at the kinds of skills that they're using and how they're using those skills. The basic structure of these prompts borrows heavily from the prompts of Kitchener and King's 1990 reflective judgment assessment, but we have done a lot of extending and adding as we have incorporated more target skills into the system. So the method that we used to develop CLAS involved 3 scoring systems, which started with the electrical assessment system, which I first began developing in the 1990s, went on to an LRJA rubric scoring system that was developed for this particular project that the data we're going to be looking at today comes from, and then going on to building the computerized electrical assessment system. Now, this makes it look like it's way more linear than it really is. We actually started the computerized electrical assessment system before we created the LRJA rubric scoring system. And we did that because we knew that the computerized system was going to be many years down the road because it was going to require a great deal of research. So the rubric scoring system was an interim system that was designed originally to make it easier for teachers to work with our assessments. So here's how the steps, a kind of idealized representation of the steps in this process. So we started with 1,325 LRJA assessments that we scored with the electrical assessment system. So the first 1,325 assessments that came in through this project were scored with the electrical assessment system. And we documented the conceptual content of every single one of these performances in a very detailed kind of way. And then we used what we learned from that to describe the sequences through which understanding developed for each of the constructs that were being targeted. And we organized these thematically after we were finished and along the way as we were doing them under categories of evidence, evaluating information, inquiry, deliberation, and perspectives. We used what we learned from this to create low inference rubrics. Now, these low inference rubrics turned out to be fairly complex because we wanted to characterize the kind of thinking that we were seeing at each one of the phases that were involved in the project. So the rubrics presented a series of these specific ways that students might understand a particular construct. And then the selections were assigned to phases, and coders made rubric selections that were good matches to the arguments made in a given performance. There were 5 to 8 clusters of thematically related rubrics per question. So you can imagine that this is a pretty big task. You're using 5 to 8 rubrics to code each question. And performances received an average score based on all of those rubric selections. So this ended up being actually a pretty accurate system, but it was laborious and impractical in the end. But it was good enough for our use here. Then we went on to use the rubrics to score about 3,804 LRJAs, and the last to score an additional 4,811 of them. And the scoring method that was used depended upon whether or not people had been trained to score with the rubrics or score with the electrical assessment system. We do have reliability and validity information for both systems as independent systems. The electrical assessment system measures the same underlying dimension as several other longitudinally validated developmental scoring systems. There's several published articles about that. Between 2002 and 2017, the Roche person separation reliability ranged from 0.91 to 0.97, depending upon the range of scores in the particular samples that we analyzed. And during this period, human raters were required to maintain an inter-rater agreement rate of 85% within 0.20 of a level. And this is continuously monitored by the system that we use to do the scoring. The LRJA rubric scoring system was calibrated to the lexical assessment system to ensure that both systems were measuring the same thing. And for a sample of 3,804 rubrics scored LRJAs, Roche person separation reliability equaled 0.91. During this period, human raters were required to maintain an inter-rater agreement rate of 85% within 0.20 of a level, which was continuously monitored. 940 assessments scored with rubrics were independently scored with the LAS, and the agreement rate was 86% within 0.20 of a level. Okay, now we are finally on to our findings. We used split half reliability approach to examine reliability of the CLAS algorithm using 9,940 human scored assessments. So here are our sample characteristics. The sample included students in grades 4 through 12. It was economically and ethnically diverse. There were over 50 schools in the US and Canada represented, and 9,940 human scored assessments, as I've already said. And the score range was 8.63 to 11.20. We randomized the sample by using the random number function in Excel. The construction sample used to create the CLAS algorithm contained 4,960 human scored LRJAs, and the test sample scored with the new CLAS algorithm contained 4,980 human scored LRJAs. And the results were that the human scores agreed with CLAS scores 86% of the time within 0.2 of a level in the construction sample. And in the test sample, they agreed with CLAS scores 85% of the time within 0.20 of a level. And we consider this to be a very good outcome. And that takes us to our discussion. There have been a lot of calls for tests that can evaluate deep understanding as opposed to correctness. CLAS essentially captures the development of understanding or meaning as it's expressed directly in verbal performances. And the reliability of LRJA CLAS scores is adequate for research and low-stakes formative use of assessments. In addition, high-stakes use is justified if growth trajectories are observed. And that was the reliability at the time of this research. The reliability actually is increased over time, and we're aiming to get to a reliability level that would justify their use in high-stakes assessment, and getting quite close right now. The lexical dictionary itself turns out to be more than just a basis for a scoring system. It's an increasingly authoritative taxonomy of the development of meaning, which up until now has not been used for very much except the calibration of CLAS. We're very interested in working with researchers who are interested in learning from this dictionary. The assessments scored with CLAS are radically formative. It's easy to get the impression from a presentation like this that what we're doing is scoring, and this is a typical assessment where the score is the last word. But these scores actually exist in the service of an approach to learning. And so the reports that come along with these assessments are highly formative and very much grounded in the research that we have done in the lexical dictionary that we've created. CLAS produces confidence scores, so they can identify many of the problems that lead to inaccurate scores, which means that we can be alerted to that a human needs to come in and adjudicate a score in many cases in which scores are problematic. But the confidence scores don't yet capture all of the problematic performances, and we're working on that, of course. And as I said, we're always looking for academic researchers who'd like to play in our sandbox. We now have well over 50,000 assessments that have been scored in our system from a wide variety of contexts. And there's much work to be done to analyze these data and tell the stories that these data have to tell. So before I close, since we have this extra time because I've recorded this, I thought you might like to have some insight into what I mean when I say that our reports are richly formative. So very briefly, I'm just going to guide you through the first tab on one of our assessment reports. And this particular assessment report, the mega skill that we're focused on is collaboration. Most reports contain at least 4 different mega skills with a set of feedback and resources for each one of them. But very often what instructors will do or educators will do is to just do one at a time so that people don't get overwhelmed by the amount of content that's in the report. And basically what we do is we let people know what the skill is that we're targeting and what the smaller skills underneath that skill are. So the mega skill here is collaboration. The next layer down focuses on self-awareness and self-control, perspective seeking and taking, communication and persuasion. Under current skills, we're listing the set of skills that we think it's likely that the individual who took this assessment, and this is based upon their phase score for the assessment, these are the skills that this individual is likely to be already practicing in to at least some extent. So we're not claiming that they're already virtuosos in these skills, but they should be able to understand what we mean by these by now, and they should be able to say, oh yes, I can tell you this is the ways that I'm using these skills. When we're debriefing one of these assessments, we actually have the person who's taking the assessment give us feedback on which ones of these are hitting home and which ones aren't, where they really believe that they have some virtuosity, where they believe they still have some work to do, so that we can create an assessment and provide them with learning activities that are going to be appropriate for where they are personally. So we've got the score that we've provided the performance that gives us some information about what they're likely to be able to do, and then we have them participate in deciding exactly what it is that they're doing and where they need to grow. The next thing that we provide is a category called What's Next. And here what we're doing is we're predicting what we think it's likely that they're going to find interesting and sexy to try doing next. So what we think is going to hit what we call their Goldilocks zone. And again, we work closely with the person who's taken this assessment to figure out what looks interesting, or we say juicy, to them. And we try to target the learning resources that we put into the assessment based upon what they have to say about what they think is going to be next for them. And this also has to do with what's going to be useful in their own particular environment as well. And then finally, we provide them with actual, more specific recommendations for learning, and actually learning tools in the form of what we call micro VCALs, and sometimes other kinds of VCALs as well, but mostly what we call micro VCALs. And these are little learning tools that are designed to do 2 things. They're designed to help people learn how to learn more effectively in real time over the course of their lifespan, but they're also designed to help them to build some of the skills that are in the report. The initial ones that we use are likely to be what we call micro VCAL starter sets, that are really simple ones that allow them to build the VCALing skills while they're practicing another skill in a way that's just not going to overload their brain. There's definitely cognitive overload potential here in the early days and weeks of learning how to micro VCAL. And then the micro VCALs always have these 4 steps: the set, seek, apply, and reflect steps. And again, in this instance, you're seeing the very simplest kind of thing. We're really just asking them to build their skills for recognizing the kind of situation in which you would practice a skill, and then to reflect upon what they're learning about that along the way. And the idea with these is that they practice them again and again and again until the skills that they're building have become automated. And I just want to finally acknowledge that the work in this paper presentation would not have been possible without the contribution of the Catalyzing Comprehension for Discussion and Debate research team, who collected the data and made it possible for us to score all of it and ask the questions that led to the calibration of CLAS.